So, are you guys able to see my screen? Okay, fine. So, if you have any questions or something in between, then just please turn on your mic and then let me know. We'll just start in 1 minute. Okay, I think we will start now. Are you guys able to hear me and see my screen? Okay, fine. Thank you. Hello everyone. My name is Hiren Solanki, and I am right now a fourth year PhD student at IIT Gandhinagar in the discipline of Earth Systems, Earth Sciences, and I work in the area of machine learning and applications in Earth Sciences, particularly for flood forecasting and basically, I also deal with remote sensing data analysis, surveying, and geomatics applications as well in our campus. So I will be going through this all your doubt solving sessions or problem solving sessions of this particular course, Advanced Geomatics Engineering. So what exactly we are going to do in this particular session is, if you have any doubt from the previous week, let's say right now from week one, from first to five videos, if you have any questions or doubt, you can ask me. If you need any help in solving the assignment question, then I will provide that as well, but not solving the entire question. And in addition to that, if there is no question or nothing is there, then we will try to solve some of the questions which will be based on the previous year's assignment or some gate examination or some other examination or basically from your content of previous week. So before going to start, as this is our first session, so I think I will request everyone just give your brief that from where do you belong and in which particular year you are of which program. Like you just have to say BTech Civil Engineering third year from XYZ college or something like that. So I think we can do that introduction and then after we can start our session. Yeah, so I'll just stop my screen sharing for a while. So can we have quick introduction of all of you guys? I think we'll start with alphabetical order. Ayush, can you go ahead? Yeah, next we have Devesh. Yeah, so next we have Harshita. Harshita, are you able to hear me? Okay, then we have Javed. Okay, yes. Can you just, if your audio is not available, just briefly mention in comment. Yeah, yes, 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 Javed. Okay, thank you for joining. Next we have Karthik. Thank you, Karthik. Then we have Sanashri Gurai. Thank you. Next we have Veer Singar. Thank you for joining. Okay, so with this, I think we will start today's session. So before going to start, I just want to know your perspective. Do you have any kind of expectation from this problem solving session, or what should we cover into this? So, any of you have any expectation so that we will try to mold this particular session into that way? Yeah. So any kind of suggestions or do you have that we should cover this kind of stuff into this doubt solving session? The one thing is that we will cover the briefs of the previous week and questions based on that. Apart from that, do you think anything else would you like to learn from this particular doubt solving session? Okay, so if you don't have anything right now, if you get something in your mind, just keep it with you and just share with me on comment or yeah. So preferably on coordinate system, geodesy, and conversions. So we will try to touch upon those topics as well. In not in this week, sorry, in this week today's lecture, but in the subsequent lectures, we'll surely try to do that. Okay, so what we are going to cover today is we'll just cover a specific question answering session for geomatics, what is geomatics, and then a couple of things related to the photogrammetry as you have gone through your videos of the first week. So let me share my screen with you. So yeah, I think it's visible now. So in case if you miss the connection or if you are not able to hear me or see my slides, just let me know by unmuting yourself any time. Okay, so let's get started. So first of all, in this particular first week, if you are a civil engineering student or geographic student, you have some of the idea that what do you mean by geomatics. So when we break down these words, then it comes like geo means earth and matics means measurements in general. So basically, we are measuring the various dimensions of earth, whether it's be XYZ coordinates or distance, angles, or whatsoever. So if you are in surveying or if you have done some courses like surveying or if you have seen somewhere outside if your home is being constructed, people do a lot of thing to measure the different kinds of uh, let's say dimension to fix the dimension of your home, to fix the angles, to fix the height. And that's like how we do the measurements. But when the measurements are very big and we want to do on earth, then it will comes to geomatics engineering. And this advanced geomatics engineering in this particular course, we are going to learn more about the advanced methods such as GPS, remote sensing, then some kind of GPR is there. So various tools and techniques are there. In addition to that, in current era, there is a high use of computers or softwares in this field of geomatics engineering to process the different kinds of images and to work with those images and to extract some information so that we can use it for decision making purposes. So that's why this field is very important as of now. And we will just try to look upon some of the questions. So what I expect you is like anyone can unmute yourself and give the answer of the questions. How these questions will follow is like these questions can be a like single correct, it might be a more than one correct, it might be a true and false, it might be a match the following, or it can be any kind of question. So you have to think and give the answer. More than one can also be correct in the same question. So this will prepare you for the different exams as well as to understand deeply in this course through reasoning. Yeah, so we'll start now. So the first question is geomatics engineering can be best described as a discipline that, so can anyone, yes, which option? Decision. Yes. So any other, anyone else, or do you agree with? Yes. Sure. So yeah, the C is the correct answer. Basically, why? Because we are using a lot of geospatial data, and then on top of that, we are using some kind of software such as GIS, and then we make a different kinds of map for decision making, and we will take the decisions according to those maps. And if you have seen that now, lots of cities are coming up with their smart city portals, which heavily use the geospatial and survey data into their domain to check whether their CCTV cameras are working properly or whether the sensors which they located for monitoring air quality or water quality are working very well or not. And if there is a issue, where is that location where the issue is, and when that sensor got faulty. So different kinds of applications we are using in. And now the next question is, so the correct answer for first one is C only. The next one is, which of the following task is not typically performed in geomatics engineering? Earthwork, anything else? Okay, so we have two options for earthwork and architectural design and construction. So let's say if I tell you that this is a just one choice question, like just one answer is correct, then what should be the answer? Okay, so this is a bit tricky question. Depends on how they asked. Like it's whether it's a single choice correction like question or multiple choice correct question. So if single choice, then it's like highly architectural design and construction because we do not use geomatics in the terms of construction like in general construction. Although we use it for making the our level perfect or our dimension perfect, but not in terms of technology or earthwork. If we consider the if we do the cutting and filling, let's say if you want to construct a highway and there is an inundating ground which is having inundations, so basically you have to do survey and you have to carry out that how much earthwork is required and all. So it's not directly relevant, but we can target on both this option. So depending on how they asked, so if it is just single choice correct question, then preferably you should go with architectural design and construction. And if it is a multiple choice, then go with earthwork as well as architectural design. Apart, if you see the option number B and C, then it includes partial analysis and modeling. So that we do using when we use remote sensing data or GIS data, we collaborate those data, mix up with different layers, and then do the modeling for floods, droughts, or any other phenomena such as landslide as well. And then cartographic map production. So in that, what we do is we whatever data we have analyzed, we prepare a map using those data sets or images which we acquired through drones or remote sensing imageries. So depending on which kind of question is, we have to answer. So I will just mark down this answer as well. But by the end of this lecture, I will provide this PPT with the proper answers with you. So do not worry about that. So I think we'll do that only. And now the third question is, which of the following is not a typical task performed in the field of geomatics engineering? Yes, yes. So all of you are right. The correct answer is C, depending on the logic which we used in this previous question. Okay, so now just a brief overview about the different components of geospatial technology or geomatics engineering. So we have four different components such as GIS, remote sensing, GPS, and UAVs. So what do you mean by those terms? So you have to match the following. So what would be the answer for this? So okay, so GIS for spatial data integration. Just a minute. Okay, so if some of you have questions, then just turn or like unmute yourself and then tell me because I'm not able to. Okay, so B will go to one. Okay, so UAV will go with aircraft-based data capture, and GPS it means the we are getting the positional information using satellites. So it will go for 3D positioning system to locate our latitude, longitude, and height, basically to get the coordinate details. Okay, so any doubt in this? Yeah. If no, then we'll move to the next question. So now, earlier it was based on what we are doing in each component. Now, what kind of applications we can do using those components or technologies? So using GPS, what can we do? True. So we are having the lat long information with us, so we can monitor how we are going to one location to another location, as we are doing in our Google Maps. Then remote sensing. Yes. So as you have mentioned in the above question, that sensor-based Earth observation. So Earth observation, it can be anything. It can be monitoring a forest or monitoring a water body or monitoring the any phenomena which is happening on Earth. Okay. Now GIS. Okay. And then photogrammetry is the living 3D modeling from images, and that images are known as stereo images. Okay. Okay, so now some of the questions based on true and false. So I think we'll go one by one. So first one is photogrammetry is only useful for taking photographs and does not yield quantitative data. So photogrammetry is what? Photo it means like we are using light and grammetry is means measurements. So we are getting measurements using the concept of light or by taking various photographs. So what is the statement is photogrammetry is only useful for taking photographs and does not yield quantitative data. Okay. So why is it false? Because here it is written that it does not yield quantitative data. But if you see the definition of photogrammetry itself, it means only that measurements. So we are getting some measurements. And because of that, we are able to quantify the different properties of the object, basically what is the length, width, or elevation, or something like that. So because of that, it is a giving quantitative estimates. So that's why the first statement is false. What about the next one? Okay. Anyone else? So why do you think it's false? Can anyone explain the logic behind that? Yes, true. So how GIS works, I mean, you will obviously learn in the further module of this course, but basically it's a geographical information system. And when you have system and it's a composition of various information, so each layer has some kind of information associated with it. Like as a student, we do have our database of name, roll number, and our other information such as address and all. Similarly, the data which we have in GIS, they also have their database associated with it. Suppose if we take a data of road network, then it will be like is it a main highway or national highway or state highway or just normal one-way road. So which kind of lanes are there? What is the width of the road? So by using all the attributes, we will create one table or database which we can link with one another data sets. So that's why it stores images as a raster or vector format, and then it is also associates data. So that's why this particular statement is false. The next one is ICT and IoT technology are used in geomatics engineering. True. Okay. So can anyone differentiate between ICT and IoT? So do you have any idea about ICT and ICT? Okay, so basically one, anyone else who wants to say anything? Anything you want to say, guys? So when we talk about ICT and IoT, I mean those two are different words. So one is related to sensor and one is related to the how we collect the data through that sensor and how we will like transfer the data with the different like basically communication and transfer and then getting some whatever data which we collect, extracting some information from it. So suppose let's say if we have flood, like if let's say Bangalore as example, and there are lots of floods coming in Bangalore. So what we will do wherever nala or something is there, we will fix the different types of sensors, and then that sensor will record that what is the level of water, and when that level will exceed, then it will start giving warnings. But what to do in case that if you want to predict that event before that only, like before 5 day or 6 day before only, or let's say just even 1 day before, then we need to get previous years of data, and then based on that data what we have to do is we have to make some kind of models using AI or ML or any kind of statistical method, and then if the conditions are like this, then it will give you the start giving the warnings. So highly it's a use of ICT and IoT where you integrate a lots of sensor communication from one sensors to your database, and then taking the information out for decision making. So next one is a terrestrial laser. Yeah. Yes. Instrument instrument control and technology. Like information communication, sorry, information communication technology and Internet of Things. Information and communication, ICT. Anything else? Okay, so the next is terrestrial laser scanner is useful for measuring the structural deformation of the bridge. True. So these laser scanners are useful for measuring the deformations or some kind of cracks if the structure is developing. or some kind of sinking if happening in a bridge. So you have heard a lots of bridges are collapsing in Gujarat or some other parts of because of rains, or they are not able to uh, handle the weight, and you will heard a lot of news based on that. So if you have this kind of scanner, we can do the monitoring of those bridges or dams or any other infrastructure project every year before monsoon. And based on that, we will see how much deformations or how much it shifted from its original locations. And if the deflections are too much, then we have to take some kind of rehabilitation measurements to avoid that consequences of it. So for this terrestrial laser scanners are useful, which will give you the precise positioning of each and every point. And most specifically for applications like dam, where we cannot go each and every location, we can measure the deflections or stresses which are generating up parts. So we do also have some kind of sensors which we can mount. So that also will give the deformations, and this is the another applications where you don't want to put sensors on the particular component, and you just use the survey instruments and you will measure the deformations. The next one is photogrammetry can only be used for capturing two-dimensional data from aerial photographs. So anything else? False. So we have one true, one false. Can you guys justify yourself? Yes. But if you read the statement properly, what is written here? Photogrammetry can only be used for capturing two-dimensional data from aerial photographs. So it's kind of outcome of it. It's written here that we are getting it from aerial photographs. Okay, so that's why this word is specifying that from aerial photographs. So it means we have already taken the photographs. Based on that, we are doing. So it should be false. Okay. Then the next one is orthophotos produced through photogrammetry are geometrically corrected to have uniform scale and can be used as a map. True. Okay. So can anyone tell me what do you mean by orthophotos? Okay. So when you heard about ortho word, so it means the first thing come to your mind is photos are taken exactly at vertical. So there is no tilt associated. It's like just taken as a, like if you have read about the orthographic projections. If so, whatever you get from the top view, exactly keeping on the top of your camera, and whatever you will project, that will you directly get the photo. So it's just kind of map only. And as it is just focusing downward only, the scale will be similar for all the pixels. If we tilt the photo like camera like this at some angle, then what will happen? The photo will become tilted, and because of that, scale will distort. So if the orthophoto is given, it means it is exactly taken at 90-degree angle. Okay, and because of that, it's having same scale. So that's why this one is true. So whenever you feel in interview or something, if you have been asked about orthophotogrammetry, then the first word should come as a 90-degree angle, at which angle you are collecting the photo. And because of that, your scale is uniform. Got it? Okay. So we'll move now to the next question. So identify the true statement. So here one statement and the reason behind that is given. So you have to say which of the following option is right. So the first statement is remote sensing can help monitor deforestation and urban sprawl. So is it true or false? True. So what is it? Yeah, it's true. So what do we do in remote sensing? Basically, yes. Okay. So the first we'll break down this sentence. Remote sensing. So what is remote sensing? That you have different satellites which is on sky. Okay, they are monitoring Earth. So they are also known as Earth observation satellites. Now these satellites will monitor the area of Earth like this. Okay, so if any forest is here, let's say we have tree which is representing forest. So now this satellite will move like in this direction and it will go after measuring this area. And after some day, it will visit the same place again. Now, if there is a deforestation, then we will able to see there is a decrease in the number of trees. Or if there is urban sprawl, it means there is an increase in number of buildings. Okay, so we will able to monitor. How? Because we are comparing the images captured at two different time period. So a satellite is constantly moving through the orbit and it will give the photo of each location again and again. It means we are getting the image of one location again and again, again and again. And based on that, we can say that whether the urban area is expanding or not, whether the deforestation is happening or not, or whether the water body is depleting or not. So now tell me what should be the answer. Both true. Okay, and then R is also the correct explanation because sequential satellite image. We will get the image every image after 6 days or one day depending on which satellite we are using. So if you go to the subsequent part of this course, you will learn more about that, which kind of satellites are available, how frequent they give the data, and all those things. So we will also do some of the practical examples of it so that you will get more idea of it. So then right is the A option, the seventh one. So now the next is arrange the following types of photogrammetry in descending order based on that technological advancement. Most recent to first. So how we used to take photo in the past and how we are collecting photo in today's era and what is the evolution throughout this period. Which one? D. Okay. 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 So, if you have gone through the lectures, you might have seen this kind of thing in the second week or second module of this week, where it started with how in 1839 we took the first photo, and it all started with the photogrammetry, and then there is advancement in the camera. So first we took the graphical photos, and then we have just films on that we will use to get photos, and then it became advanced like that, and we got the analytical, and then subsequently right now in today's era we are getting the digital photos after 1988. So the next question is which of the following company is not a geospatial software provider in India? Yes, D. Okay. So can anyone tell me what does it provide if not software? So have you heard the name Somkia? What do they do? I mean, the name of that company. So basically, this company produce different kinds of survey instruments. So they give the instrument part or hardware part rather than giving a software or service. So the next one is find the correct statement where you have to just know more about photogrammetry and remote sensing. So before I think, can anyone tell me the basic difference? What do you mean by photogrammetry and what do you mean by sensing? And how both are different, both are same, right? So what is your take on that? Yes, true. That's true. Yes, yes, true. Anyone else wants? Yeah. Wo- Okay. So yes, anyone else? Yes, yes. Go ahead. Photogrammetry, exactly. But see, like if you have heard the photogrammetry, okay, in the it's a, if I am using drone and yeah, I am collecting images at different angles, I can generate the 3D map, and that is also known as a photogrammetry. So I don't think so. It's active because we are just using the natural light and we are collecting the images. So photogrammetry can be active, can be passive, depending on which sensor we are using. If I have put a LiDAR sensor to measure the accurate positioning, then in that case photogrammetry will become active sensor. But if I am using natural light, then in that case it can become passive sensor as well. So those who don't know active and passive, it means what we are talking about here is, let's say you have your camera, okay, and you are getting a some kind of image of some particular object. Okay, so how you will get that image? Because sunlight is falling on that particular object and that is being reflected. So that energy which is coming from the sun, basically, if you see here, sun, and whatever the energy which is like reflecting back from the object, that your phone is capturing. And like that, you are able to click the photos. So same thing will happen in photogrammetry. That energy is coming from sun, and then the camera which you mounted on your aircraft, it will sense those energy. So that is known as just you are taking the photogrammetry. But sometimes if you are doing that, if sunlight is not available or the area is very shady or something like that, then in that case you use your own sensor as well. You put some sensors here on your aircraft. It will radiate the data or waves, and that waves will come back and record into your instrument. So you have laser or LiDAR sensors as well. So that is known as active when you are not using sun's energy. But if you are using energy of sun, then it is known as a passive. So if you take example of photogrammetry and remote sensing, it can be active or it can be passive depending on what source or what satellite you are referring. So the option C, that both photogrammetry and remote sensing are limited to passive sensor, that is wrong for sure. So that is not correct, but because it can include active sensor also or it can include passive sensor. And just think like if you want to collect the data at night time, how will you do? Because night time we don't have any images. Oh, sorry, no, we do not have any reflected energy. So we do have our sensor. Hello, hello, can you repeat? My voice is not clear. Okay, so are you able to hear me now properly? Okay. So what I am telling is, uh, either in photogrammetry or remote sensing, it depends on how we are getting the images. So if we are using natural light, which is provided by sun, then it is known as a passive remote sensing or passive photogrammetry. But if the sun's radiations are not available to sense, in that case, we will illuminate the object through some artificial light such as laser or LiDAR, okay, or something kind of other kind of active remote sensing. That is known as active remote sensing, where we are throwing lasers or lights on the object and that we are getting back. So that's why the option C is wrong, because both either photogrammetry or remote sensing, they can use active or passive sensor both. Now we have to do something on first, second, third, and we'll come back to the original difference between photogrammetry and remote sensing. So, so what do you do in photogrammetry? Basically, you capture the different images, and then what you do with that imagery, that is image is known as a stereo images. So using those stereo images, you create a 3D model out of it. Okay, so basically you are more interested in geometry of the object or terrain, how your terrain or surface will look like. So we are emphasizing more on the geometry when we are doing photo. On the other hand, remote sensing is sensing something. I mean, what we cannot see through our eyes, like we sense the energy in infrared, we sense the energy in ultraviolet, we sense the energy in RGB bands using remote sensing. So we are having different wavelength, and that wavelength we are using to give the spectral, like how my object will behave under various wavelength. So that is known as a spectral analysis. So that is being more focused on remote sensing. So remote sensing emphasizes on spectral analysis from sensor data across the different wavelength. So that is also true. So the option A and B are correct. Option C is wrong. And the third one is remote sensing cannot be carried out by mounting the active sensors like SAR for data acquisition. So in nutshell, if I want to differentiate between these two, then photogrammetry is mostly on aircrafts or it's near to the surface. Whereas remote sensing, it can be anything. It can be aircraft, it can be a drone, it can be a satellite. The basic terminology of remote sensing is sensing something without being in touch with those objects. Or it might be in any wavelength, in any sensor or any data. So if you want to incorporate photogrammetry, like how you capture the photo in photogrammetry, that will come under remote sensing. But it's not same. In photogrammetry, you are just focused on 3D reconstruction or height and other information, height, slope, and basically which will specify the geometry rather than how it will behave under different wavelength. So are you guys able to get the difference between these two words? Any doubt in this? Okay, so here the first and second options are correct. The next one is, which of the following are benefits of using geomatics in large scale infrastructure projects? So here can you think it might be a multiple choice question also, like more than one might also be correct. Okay. So A, okay. So how increased transparency is means like, see, earlier what I used to happen is we go to the field and we collect the data using manual or humans. Humans do the all the collection, data collection. So there is a error which is created by human. Forgot to mention some number. Or instead of 101.1, you have written 110.1 or something like that. So in that case, what will happen that now if we collect the data through different instruments, we will get to know that what is the data value which we have recorded. So it will improve the transparency. Or what used to happen is like if area used to be very large, then we do the survey, we divide our entire survey into different days. One part we do in the first day, then another part in second day, third day. And you will see in a lot of structures. Like they started one part from the left hand, part from the right hand. Then both are not matching with each other, or both are having some kind of difference in the dimensions. So that thing will not happen if we will improve this geospatial or basically use of GIS, drone through monitoring and all those things in large scale infrastructure. Because it will be like more number of days will be and high cost. Although it is high cost, but it will reduce a lot of work. So if you go a large scale project, it will reduce the cost of manual service substantially, because otherwise, like if you want to do a highway, if you want to construct a highway, then you have to do a lots of reconnaissance survey where you will find out first 5 or 6 different routes, and then you do the detailed investigation of selected 3 routes, and then you will come up with any one route at the end. So if we have data obtained through drones or aircraft or satellites, then it will be helpful very easily and quickly information without going to site. So that's why it will like significantly reduce the cost when the large scale in projects is involved. If small scale project is there, then in that case, yes, this project will cost a lot. But here the word large scale is there, so for that, it cost will be like minimal of for using this instruments or this technology. Any doubt? Okay. So now the next question is in comparing maps and aerial photographs, the clarity of details is so in which you will get more clarity in map or in photo. What might be the true option out of this four? Mhm. Okay. Anyone else? More on photo than map. Anything else? Any other option, guys? So can you see the options here? I mean, it's like kind of if you think, see, just see the option. Do you see any similarity between option D and option A? So do you see anything there like option A and D? So don't you think both are same? So what does A represents? Less on map than on photo. So that, like, you will get less information on map compared to photo, and you will get more information on photo than map. So don't you think both are similar? Ultimately, they are like similar words, just they change the wordings here and there. Okay, so here our answer will be both A and D, because ultimately both have similar options. So the next one is which of the following can be effectively used as substitute for a map? Okay, anyone else? A, B, and D. Okay, one per A, B, and D. One is saying A, B, and D. Anyone else? So now what I can say is that there is just one correct option, not the multiple choice. And you have to justify also why. See, what we are referring here is substitute of map. And map will be a larger, it will display a larger picture rather than just a single photograph. And earlier we only told, like I just told, that if we have 90-degree photo, which is taken from any image from satellite or aircraft, then it will behave same as a map. But one photo is not enough because it will just cover some part of the area. So instead of one photo, you have to take a photo mosaic, that you have to consider a multiple photos and you have to stitch them with each other. And that it will become a substitute of map, because when we say map, it's a bit bigger one other than just one photo. So here the correct option will be D, which is vertical aerial. So vertical aerial, either B and D, but here they are specifically referring to map. Then our correct answer is vertical aerial photo. Any doubt? Yes. Yes. So generally, what will happen when we will collect image through photo? So it will just create one particular patch of particular area. But when we refer to word map, it will represent a bigger area. And for that, just one photo is not enough. The map, when you consider, map will have larger area and less details, as we discussed in previous question. So in that, what will happen, that you will be having multiple photos. So these are the different photos captured in the same area. So photo number one, photo number two, photo number three, photo number four, and then what you will do, you will stitch all the photographs with each other. That is known as a photo mosaic, and then it will give a larger view. Is it? Did you get my point now? Okay, so the correct answer is vertical aerial photo, but with mosaic. As map will show more area, but lesser details. So there will be lesser detail in map, but the area will be large. The next one is scale. So scale is, so what is the definition of scale? A. Yes. Anyone else? So yes. So the scale is the ratio of distance on a photograph or a map to its corresponding distance on graph, that is known as a scale. Okay, so before we go forward, are you guys comfortable with my speed? Is it fast or slow? Okay, so in between, if you find something is problematic, then just please let me know if we are going too fast or too slow. So let me know. Okay, yeah. So now what we will do is we will solve some of the numerical questions on scale. So what we discussed in the previous question is scale is the ratio of distance on map to distance on ground. So here, if the plotting accuracy of a map is 0.25 mm and the scale of the map is 1 raised to 100,000, then what will be the minimum ground distance that can be plotted on map? So how will we approach to this problem is first we understand the definition of scale. So what is scale is? Scale is the distance on map to distance on ground. So 1 mm. Why am I writing mm? Because it is given that if the plotting accuracy of map is 0.25 mm, it means the unit of maps are in mm. So here what it's suggesting is the scale of map is equal to 1 mm is equal to 100,000 mm. Okay, so like this we will decode first. Now what is the accuracy of map is 0.25. So we can measure any particular thing if it is equal to or greater than 0.25 mm. So that is the accuracy which we can achieve through map. So first of all we will convert that into a same distance on ground. So if something measures 0.25 mm on map, so if something is measuring 0.25 mm on map, then how much it will be on ground? Okay, 2.5. Anyone else? Yes. So what I'm saying is here first we have to decode from the things which is given to us. Okay. So what it is given to us is the accuracy is 0.25 and the scale is 1 raised to 100,000. It means if it is 1 mm on map, then it is 100,000 mm on ground. And if you convert this into meter, then it will be, if you convert this mm into meter, then you will get, you have to divide by 1000. So you will end up with 100 meter. So 1 mm on map is represented by 100 meter on ground. So if you have a stretch of 100 meter on ground, in map you will find 1 mm. But now in map you have accuracy of 0.25 mm. So how will it relate to ground? It means we just have to do cross multiplication here. So if you multiply 0.25 with 100, it will become 25. Okay, it will become 25, not the 2.5. And that is the minimum ground distance which we can plot on map because the accuracy is 0.25. So are you guys clear with my explanation or should I repeat? Okay, okay. Others got the same answer or you got the point which I'm trying to convey? Okay. So the next question is a line measures 15 centimeter on aerial photograph. So we have one photograph in which there is one line which is 15 centimeter. Why? It measures 5 centimeter on a map. Okay, so now see, we have two different things. So earlier in question, what we discussed is we discussed the difference between aerial photograph and map. So here we have one photograph and we have for same location, we have one map like this. Now one line is there. This is our photograph P and this is our map M. And this line is measures 15 centimeter on photograph. So 15 centimeter on photograph and it measures 5 centimeter on map. So here on map it is 5 centimeter. The same line will be 5 centimeter. Okay, at a scale of 1 to the 24,000 scale. So the scale for map is 1 raised to 24,000. Okay. Now let's decode the question further. The photograph was taken using the camera lens. Now they are talking about photograph. What photograph? So photograph was taken using a camera lens of 20 centimeter focal length. So for this photograph, the f, which is the focal length, is equal to 20 centimeter. Okay. Average elevation of terrain is 240 meter above the mean sea level. So this is referred when we take the photograph. So H average is equal to 240 meter. Okay. Now the flying height of the aircraft above the mean sea level is fill in the blank. So you have to find out the height of the aircraft, which is denoted by H. So if you have gone through the lectures, then there is a formula for scale, which is that your scale is equal to focal length f divided by h minus h average, where h is the height of the aircraft and then h average is the average height of the terrain. Okay, average height. Now for this is for aircraft. So for that f we have, which is 20 centimeter. So f we have, we can replace it with the 20 centimeter. Now h, this we have to find out because we don't have this. This is the things which asked in question. Average height, which is also given, which is 240 meter. This 240 meter is given. This 20 centimeter is given. These two things are given. Now we have to find the scale. So what is scale? So what we discussed in the previous question, scale is the ratio of distance on image or map divided by distance on ground. Is that clear? Okay, so for this image, do we have anything out of this? So we have distance on image or map. Do we have that, which is 50? Okay. So image on, like, sorry, distance on image, because here we are talking about image only, divided by distance on ground. Distance on ground. F we have, how much F we have, which is 20 centimeter. And then H we don't have, and then we have 240 meter. Okay, and this 20 is in centimeter. Okay, now we are with two unknown variable, H and distance on ground. But if you see in question, they have given us some other data as well. they are given the data of map. What map? So for that map, what is given is the same line measures 5 centimeter map. So for map, if and the scale is also given for map. So for map, if you want to write, then the scale for map is 1 raised to 24,000. And what is the definition of scale? Distance on map or image divided by distance on ground. So distance on map is how much? 5 centimeter. So here we have 5 centimeter. And distance on ground is not known to us. Okay. Exactly. So what we will do, we will get the DG value from here, and that value we will plug into this format. And based on that, we will get the value of H. Can anyone do the calculation and get back with the answer? So do you guys understood the question? If you still didn't get the question, let me know. I will explain again. So what this question is doing, it is combining the what you have learned till now into same thing. The definition of scale, the difference between photograph and map, and the formula for finding out scale. Anyone else? Yes. So please take care of all the units. Mhm. Anyone else got the answer? Okay. So we will now see the solution. Um, so we will get the first of all value of the scale, and then we'll plug that here. So our actual answer will be 1840. So if you have done any mistake, then it might be in the conversion of different units. Okay. So basically you will get the answer 1840 meter. Any doubt in this question? Basically in the concept of this question. Any doubt? Okay, then we'll go to the next question. So what are the Manhattan and Pythagoras distance uh, with respect to point A and B in the figure given below, where the Euclidean distance between A and C is 4. So what you have to mean is the each box represents 1. So this length is 1. So if you don't know the concept between Manhattan and Pythagoras distance, I will give you the brief. What does that mean? So if given two different points A and B, then in that case, if you go from A to B, then what will happen? If you go diagonally, then it will be considered as a Pythagoras distance, as you do using your Pythagoras theorem. However, if you do, yes, 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 and Manhattan distance, it means you have to go line by line only. You cannot go diagonal. So as you, yes, true. Okay, so the correct option will be B. Okay, so Manhattan distance it means like you have to go. You can go here like this, to like this. Then it will be 4 plus 4 8. Or else what you can do is you can go 2, 3, 4, 5, 6, 7, 8. So you can go in any way, but you don't have to go diagonally. 1, 2, 3, 4, 5, 6, 7, and 8. So it will be ended with 8 only. Whereas the Pythagoras distance will be the minimum distance between A and 2, which will be like this. So if this is 4, this is 4, then that will become 4 by 4 root. Okay. So the next question is, which of the following map scale is more suitable for urban planning? So here you have to stress more upon the definition of scale. Distance on map or image to distance on ground. So first of, yes, anyone else? So the one answer which we got is 1 to the 10,000. Anything else? So what I want to say here is, if you have urban thing, then you need very high resolution. It means the like distance on map should be very high resolution distance. So in which of the following you see, like if it is same distance on map, then it will represent very high information. A. The answer is A. 1 to the 10,000, because it's just higher resolution scale. Why? Because here, if we consider both in mm, then 1 mm is representing 10,000 mm. It means 10 meter. So 10 meter on ground is represented by 1 mm. Here 25 meter on ground is represented by 1 mm. 50 meter on ground is represented by 1. And here 100 meter on ground is represented by 1. So maximum detail we will get in the first case. The next question is the representative fraction RF of the geographical scale given below. Where which is 1 raised to x. So what will be the value of x? 100. Okay. Anyone else? 0. Anything else? So we got two answers till now. 100 and 0. One is 100 and one is 0. So you have to see entire scale. Any other answer? Anyone? So let's decode this question. 10,000. Okay. The third answer is 10,000. Now let's see which one is right. We got option A, option B, and option C. Okay, let's see. So what do you see here is 1 centimeter is equal to 100 meter. So 1 centimeter is equal to 100 meter. Okay. Now, when we represent as a representative fraction, we have to make the unit same both sides. So either both side centimeter or both side meter. So if we convert both side unit into centimeter, 100 meter will become, we have to convert meter into centimeter. So we will make it 1 meter is equal to 100 centimeter. Okay. So now from this centimeter will go and you will get end up with 1 to the 10,000. So your correct answer should be 1 to the 10,000. And in this question, you have been asked x only, not 1 to the x, 1 to the like 1 by x. So your answer will be just x. So this will be your x, which is 10,000. So the first answer you haven't considered this unit. The second answer where we got 0, you just consider the first part only. But in map, you have to see the entire scale. Okay, so the correct answer is 10,000. Any question? Okay, so the next one is which of the following map scale has the lowest detail? So if you are having this four kind of maps, which of the following has lowest details? So I will give you one hint that convert everything into same unit, all the four options. D. Okay, great guys. The correct answer is D only. So D has 1 to the 100. It means it is having lowest detail. And if I ask you in this question, which of the following has highest detail? Then it's B. Okay. Any doubt? Okay. Still any doubt? Any confusion? Okay. So you have to focus on the given words. Okay. Still any doubt? Okay. So those who gave the answer D, can you explain the logic? I think we will just write everything into scale format. So here we will get 1 to the 1000. Then we will have here in the second case where we will have 1 to the 10,000. Then C option we will have 1 to the 1000. So ultimately if you see here the option A and C both are similar. And then if you see here the last question, then it has 1. And what is being asked in the question? Okay, so you guys are confused between the, yes. So how you have to see 1 Earlier, you just have to focus on the definition of scale. So what is the definition of scale is distance on map or image divided by distance on ground. Okay. So if here you see 1 mm on map and here is equivalent to 100 mm on ground. So if you are representing 100 mm into just one part and here you are representing 10,000 mm into one. Okay, so here it means this is the big line in ground and you are taking a small out of it. In the option number D, you are having this small line and that you are representing with the same in a map. So if you see in terms of details, highest details that will be captured by option number D. But the minimal details will captured by this. So in our case, the correct answer is option number B if the question is lowest detail. If it is highest detail, then the option D is correct. Both of you got your doubt clear, or is there any still doubt is there? Both of you? Okay. So here I mean see if they will ask you a 2 or 3 different terminologies. The first thing they can ask you is in terms of details that which scale has highest detail or which scale has lowest detail. Then another case is which scale can cover larger area and which scale can cover smaller area. See, they are just changing the word. Which of the following map scale has larger area? Which of the following map scale can cover larger area? So larger area means what? If you are representing a very big line into small chunks, it means you can cover more area while in a map. So if they ask you in terms of which of the following scale has highest area, then in that case it will be highest area, it will correspond to the lowest detail, and highest detail will correspond to the lowest area. So both things are vice versa. You got my point? Okay. So what I'm saying is when you are telling that detailing, okay. So in terms of detailing, what I'm saying is 1 mm on, sorry, 100 mm on ground will be represented by 1 mm on map. It means you are having a line of 100 that will be represented by 1. Okay. And in this case, where you have B, line of 10,000 mm. So this line of is 100 and this is 10,000 mm. So this 10,000 mm line will also be represented by 1 mm. So which will give you high detail because in this you can see the length is very less. So this map where you have this thing 1:100, it will give you the highest detail. So here you will get detail high. Whereas, so here I will write details. Okay, and here you can see the line which you have drawn is very big line that you are representing using small line. It means in the first case, the detail will be less. Why? Because line length is very big. So detail it will not capture. But now if I say in terms of area or scale or how much area it can cover, then if I have similar map, if I have two map, this map and this map, and in one map I have this scale, scale number 1, and in one I have scale number 2. So here details are very less. It means I can represent a lot of area because I am not doing much detailing so that I can cover large number of area. Basically, I can taking my photograph from above. Like I'm moving my satellite or aircraft up, so that it will capture a more area with less details. So here what you have to think is, let's say, are you able to see my video right now? Okay, so what I am just focus on my video. See, this is my surface and this is your camera. Okay, so if you go up like this, it can cover larger area. Okay, but what will happen simultaneously that if you take photo from far away, then you will not see the detailed photo. You will see very blur thing. You will not see the flower properly. It will just be a some kind of color. So as I will move away from my photograph, my scale will, like detailing will decrease. And the area which I can cover, if I go like this, the area which I can cover is increasing. So there is a trade-off between how much detail I need and how much area I want to cover. So both are vice versa. If I need more details, then area will be minimal. And if I need less details, then I can cover a larger area. Is it clear now? Okay. So next question is, what is the typical positional accuracy range of LiDAR? So if you have LiDAR technology, what is the typical, so this is just a memorization question. Uh, Anyone remembers what is the typical accuracy of LiDAR? You can refer your notes also. Okay. And in horizontal direction, how much? Any option is right. In horizontal also. I don't agree with you because see, like if the accuracy is good in vertical and horizontal both, we should be able to precisely map and 30 to 60 horizontally. Why? See, you can take anything, whether it's a LiDAR or whether it's a GPS. They are very worse in the vertical dimension. They are not able to capture the vertical dimension. Height information you will not get very clear, but the horizontal information you will get very clear. If you use your Google Map also, you will exactly know how you are going from one location to other location. If you just move across the north direction or left direction, it will pinpoint your location properly. But if you are going up, let's say one floor to another floor, it will show you same as it is only. Because this GPS are very poor in getting the vertical data. And that's why if you take any surveying operations, the vertical accuracy is very less compared to the horizontal accuracy in any of the case. But in LiDAR, still we got very high accuracy in vertical dimension as well. But still it is less as compared to the horizontal accuracy. So the correct option is C and D. The next one is, which of the following cannot be detected using terrestrial laser scanner? So terrestrial laser scanner is like you just mounted one instrument on ground and you are taking a bunch of readings using it. So we have two different things. One is aerial sensor and then is which we kept on aircraft or drone, and terrestrial means we just kept that mounted on some kind of ground. Right? So which of the following is, because it is below the ground, so we cannot monitor those things using terrestrial scanner. Okay. Now, which of the following method is useful for subsurface detection? So, coming back to your question, that if we now, yes, true. So, GPR is a technology. Can anyone give me the full form of GPR? Okay, sure. The next question is, so now we will move towards the bit on photogrammetry definitions. Point the tilted photograph, where the bisector of the angle isocenter. So this is just a definition. So basically, they are referring to this thing. So this is your camera axis, and then what is given is the point on the tilted photograph. So this photograph is tilted, as you can see here, where the bisector of angle of tilt. Angle of tilt is the angle between these nadir and the camera axis. So this is your angle of tilt, theta. So the bisector of angle of tilt, which means this, which will divide into theta by 2, theta by 2. Bisector of angle of tilt strikes the photograph. So the point where this bisector will cross this particular photograph, that is known as a isocenter. Then the next one is increasing the angle of tilt in aerial photogrammetry may lead to. So now what they are saying is, if this angle is there, okay, now we will increase this angle, because see, this line is fixed. This nadir line is 90-degree line. So this is fixed. But now what I am doing is, this line is there. I am changing this line to increase this theta. So I am moving this line like this. So what will happen to photo? Okay. So my image will become like this. Okay. So why the other options are wrong? I am more interested in knowing that. So if you are saying is the option number A is right, it means you are also right. I mean that it will obviously capture the more area. But I want to know why the other options are wrong. Exactly. Yes, exactly. True. True. So your logic is true for all the options. So now we'll move to the next question, which is the angle of tilt in aerial photogrammetry is defined as the angle between. So this we already talked. This is the angle between. So which of the following is right here? Anyone else? Flight or plumb? Which one? A or B? A. Flight line will be this one here, like this. So your camera axis is this one. So you are referring to this angle. So that is not the tilted angle. This is 90 minus tilted angle. So 90 minus theta. So what you are referring in option number A, that is 90 minus theta, not the theta. But plumb line and nadir line both are 90-degree line. So here they have used two different words. One is plumb and one is nadir. Both are similar only in terms of this definition. So your correct option will be this one, camera axis and plumb line. So basically this nadir line. So this angle will become this. This is your camera axis like this. So this is your camera axis and this is your plumb line or nadir line. So the angle between these two is known as the angle of tilt. And this is your flight line. So the angle which you will get here, that will be 90 minus theta. So 90 minus tilt angle, not the tilt angle. Okay. Next. So the scale of vertical aerial photograph of inundating terrain is. So here I have given the formula also to think you which one should be right. S is scale, F is your focal length, capital H is the height of flight, and H average is the average elevation of your terrain. So if you are not able to find out which one is right, can you tell me which one is wrong for sure? See, if you see here, S is your scale, F is the focal length. So both are directly. Okay. Anyone else? Are you agree with this answer? Okay, so let's decode it. We'll go from D to A. So uniform throughout the photograph. As the photograph is like unundating, like terrain is unundating terrain, it means there is a much more fluctuations in height. The scale will not be uniform, it will be varying because this H average is not constant. So that's why we have to take H average and that's why it's not uniform. So this is wrong. Then directly proportional to the flying height of the aircraft. So if you increase this, what will happen? If you increase H, then this denominator will become big and then why that's why S will become less. So rather than directly proportional, it is indirectly proportional or inversely proportional. So that's why option C is wrong. Now inversely proportional to the focal length of camera. So it is directly proportional because if you increase F, S will increase. So it is directly proportional, not the indirectly proportional. So option B is also wrong. And now comes to the last part, which is H average, average height of the terrain. So if you will increase this H average, what will happen? Let's assume your H is constant. So if you increase your H average, then this denominator will become entirely it will become less. Because if you deduct something more high and high, it will become less. And if it will become less, this will become high. So basically, if you increase H average, then S will also increase. And that's why it is directly proportional to the length of terrain. That's why option A is correct. Any doubt? Okay, so now we'll move to the next question. So isocenter of a tilted photograph. So this we have already discussed. So can anyone just go ahead and quickly give the answer? Sure. So option D is correct. We have just discussed this in the previous question. Now the next one is for constant flying height. So H is fixed. Your capital H is fixed. The average scale of an aerial photograph depends on which of the following parameter. So it's similar to the previous question. Question number 27. Topography of ground. Anything else? So what was the formula? Scale is equal to focal length. Then do you see focal length in H minus H average? Do you see any other variable in the options? Yes. So option A and D both are correct. Now the next one is select the odd one out. So which of the following is like different than its other? The first one is contact prints, film positive or dipositives, stereo photos, and digital. Contact prints. Okay. Anything else? Contact prints. So the correct option here is digital photos, because digital is on computer, whereas these three are the traditional techniques in which you will get photo in a paper or in terms of some kind of surface. Contact print. So this is the evolution of photograph. Contact prints, which generally used to be 23 by 23 meter, uh, like that. Then fill positive and dye positives, and then stereo photos, and then you have this digital photos. So the next one is, what is the primary purpose of overlap between successive aerial photographs in photography? Yes. Okay. Next is the minimum forward and side overlap, which are generally we should keep, are okay. So 60 and 25. 60 in forward and 25, 20 to 30 in side. The next one, which of the following statements about photogrammetric overlaps are correct? Can you tell me again? Yeah. So anyone else? Is C correct or not? Is C correct or not? Is option C correct or incorrect? Anyone else? The other three are right. Let's talk about C. So when you do the survey using GPS, but tell me, like, the answer is lying in this slide only. The question number 31 has the answer. Why do we need overlap? Because we want to have ensure that some common part should be there in image. And how GPS will help us? It will just give us the location only. It will not ensure that same part is coming or not. It will just give the location of point. But why do we do photogrammetry? So that same kind of things will be there in both the photos, and then using that we will generate the 3D model. So the main goal of this overlap are to reconstruct the 3D view, and that's why we need overlap. So whether we are using GPS or not, that doesn't matter. We need overlap. So that's why the option C is wrong. Our main purpose is just to ensure the common area. GPS will give you the precise location, but not the common area. Okay. Now let's move to the some of the question answers for this side labs and overlaps. So the aerial photographs are taken at a scale of 1 to the 10,000 using a camera with a focal length of 152 mm. The size of photograph or photo format is 230 mm by 230. If the required forward overlap is 60%, compute the distance between successive exposures along the light line. So I will just give you the what they are asking question, and then you can try solve this. So let's say this is our aircraft and it captured one photo like this. Now this aircraft will move forward, let's say here, and it captured the another photo of the location. Okay, so what we have to find is compute the distance between successive exposure. So here I'm taking one photo. So this is the one photo which I have taken, and then this is the another photo which I have taken. And what I have to find out is the distance between these two stations. Okay, and for that what details are given to us is that this overlap which is there in the both the image is how much? 60%. So the overlap is 60%. What else is given to us is aerial photograph are taken at a scale of 1 to the 10,000. So the photograph which we will receive over here at aircraft, it will have scale of 1 to the 10,000. So scale here is 1 to the power 10,000. Sorry, 1 raised to 10,000. And focal length is f. F is given. So when f is given, scale is given, which formula we should recall is formula of scale. Scale is equal to focal length f divided by your h, which is like, so basically h minus h average, but here we do not have any h or h average. So this formula will not work out. But what is given to us is photo format, which is 230 by 230. It means the photo which I am getting here is 230 by 230. So I know this photo is 230. Like length and width of this photo is 230. So if it represents 230 here, then what will be the 230 on ground that I want to see? So for that we have standard definition of scale. That scale is the distance on map or image, which is 230 mm, divided by the distance on ground. So that we will find because we don't know. And scale we already know that it is 1 to the power 1 raised to 10,000. So how much we will get here? So if we convert this 230, everything let's consider in mm only. And if we want to convert this into meter, then what we'll do, we'll divide it by 1000. So x will be 230 into 10,000, and then it will be have to divide it by 1000. So 3 points will go, and it will be like 2300 meter. So the distance on ground will be 2300 meter. Okay. So this distance which we got is 2300. This and this. It's not on scale, but this distance and this distance are 2300. Now this particular thing is 60, and whatever is remaining is will be 40. So like every time this image will be separated by 40% of area because 60% is common in both. So the difference between the two stations will be directly equal to be 40% of this entire data, because here it will capture the one image and then it will go here, and then as 60% area is already same, then it will consider 40 and then again 60 with the other image. So this will be like, if this is the 60%, then between these two will become 40%. So what is the 40% of this entire thing is 2300, and 40% of, but what they asked is they ask us the distance between these two exposure stations. So aircraft has taken one photo from here and one photo from here. So they asked us the distance between these two only, not the total distance. Okay, so that's what I'm saying. This distance between these two exposure will be 1 minus common area. So 1 minus common area is how much? 60% area. It means it's 0.6. So which will result into 0.4. So 0.4 of how much area it is covering, image area, which is 2300. So 0.4 into 2300. So it will, if you do this, and then it will become 900 and around how much? 0.4 into 230. If you do, it will become 920 around. So your answer will be 920 meters. Anything doubt? Okay. So the next question, uh, a survey area of 15 kilometer long and requires a forward overlap of 60%. If each photo covers 2300 meter along the flight line, then how many photos we have to take? So I will just remove this ink. So what is given to us is survey area is 15 kilometer long. Let's say 15 kilometer long line. And then overlap is 60%. And each photo covers 2.3 kilometer. Okay, so we will have first 2.3 kilometer and then we have to overlap it by 60%. So 60% we will overlap and then we will take another photo. Again 60% we will overlap and we will take the third photo. Again 60% we will overlap and we will take the next photo. Again 60% we will overlap and we will take the another photo. So like this, if you want to cover from point A, point B, how many photos are in? So you can see like how much we are getting in every photo. We are getting amount this much amount of distance, this x. And what is this x? This is our common distance, which is overlap, which is 60% overlap. See this much. So if this is 60%, then how much this will be? The x will be 0.4 or 40%. If the overlap is 60%, non-overlapping part will be 40%. So 40% of which will become 920. So every time this x will be 920. 920 meter. Now what you have to do is you have to divide your entire length by 920. So how much distance do you have? 15 kilometer. So divide 1500, like we will convert it to meter, divided by 920. Okay. Anyone else? So you will go get around 16 point something. So it will become into 17 photos. But here is the catch. What will happen? Like the last photo, it will be like, see, this is the difference. Like this is the first photo, second photo. So this are giving intervals, not the number of photos. This is the first interval, second interval, third interval, fourth interval, fifth interval. So if you go like that end, you will be end up with one more photo because this portion is captured, not this portion. Okay, so if see, I am taking one photo and second photo, then this area which is being captured is by the first photograph, not the second photograph. What X is giving us is the interval between the first photo and second photo. Okay, so whatever the you will get the number of intervals, and to convert into number of photos, you have to add one. So your answer will become 80 rather than 70. So what I suggest, just think if you don't understand this part, just put the like just use some Desmos or any kind of if you AutoCAD, or if you just have scale, draw this thing using scale and see how many times it is doing. So basically, if when you divide 1500 by 920, you will get the interval, not the number of photos. Is that, did you get that point or not? Okay. So total will be 18 numbers of photos are required rather than 70. So the next question will be like if the width of coverage per photo is 2300 and the side overlap is 30. Now we are talking about side overlap. Then what is the distance between adjacent line? So here what we have to do is, so here we are doing two photographs which are adjacent to each other rather than basically it has side length which is 30%. This is 30%. So what is the like distance between this adjacent two flight? So similar to like earlier question we used to do, if 30% is common, we will take the rest of the distance which is 0.7. So it will be like 0.7 into 2300. So in the first question, when we calculated the distance between two air bases, it's similar to that distance between the two adjacent lines. So it will be 1 minus overlap region into the width or height of the length of. So 0.7 into 2300. So it will become around 1610 times. You got my point? So we are doing the same as what we discussed in the first question. Like here, what we did is 1 minus zero point 0.4 into 230, like converted into similar thing we are doing that. So 1 minus zero point 0.3, which will be 0.7 into photo, which will be become 1610. The next question is an area of 10 kilometer by 8 kilometer is to be covered using the aerial photograph of 60% forward and 30% side. So each photo will cover 2.3 by 2.3 kilometers. So how many flights we have to cover? So in the lecture, you might have seen this kind of diagram that if you want to study an area, then you will flight like this to cover an area. So basically, you will take the photographs here at those locations like this. So in question, they are asking if side overlap is 30% and forward overlap is 60%. And if you want to cover this much area, 10 kilometer by 8 kilometer, then how many flights are there? This will be like one flight, second flight, third flight, fourth flight. So I think because of time constraint, we will not go into much more speed. So I will upload this slide and you can go through the same content. You will get this link into your classroom. If you don't get, you can get back to me through my email ID. I will ask you these questions which are remaining after. If you don't get it, then just let me know. We'll discuss the same thing in the next question, next step also. There are a few questions which are still remaining on scale and overlap. Which will discuss in the next session. Before that, before stopping this session, I just want to get feedback from you guys. How should we conduct the next class? In the same way, or if you need some brief about the topics which have been already covered in class, then also I can cover that. But better like if we understand those concepts using like numericals or MCQs, then it will be good to go back and so that will be helpful to you in exam as well and understanding concept more properly. Any other suggestion, guys? And in meanwhile, like if whenever if you think my pace is going bit fast, please slow me down at any point of time. Okay. So hope you enjoyed this session, and we will close this session now, and we'll meet on next Saturday at the same timing using the same link. Meanwhile, I will upload all the questions into OneDrive, and you can go through those things if you have any questions in that, as well as you have any questions in your NPTEL classes or any other assignments. If you need that hint, then please let me know either in discussion forum or just write a mail to me. I will be happy to answer you. That's it. Thank you. Thank you everyone for joining. So thank you everyone. Bye bye.